Hi, I'm Oscar Castillo. I'm an engineer and project manager at Northrop Grumman Corporation. Like my father, I'm also a small business person. I create virtual tours for schools and event spaces, as well as operate an e-commerce store with my family. I'm also an immigrant, originally from Peru, a country in South America. Finally, I'm a father of two, a 10-year-old son and a 12-year-old daughter. Now, it's my hope today to get you all excited and interested in the future of engineering and properly invite you all to participate in shaping that future. I'm a big advocate for students to learn about engineering, science, technology, math. In particular, I'm going to share a few examples of how technology, something I am passionate about, is changing how engineers design and build products. Some of the technologies that are changing the game are virtual reality, augmented reality, additive manufacturing, and artificial intelligence. There are many more that I'd like to talk about, but I can only fit so much into this short talk. Also, it's really okay if you don't know what all those terms mean. I'll try to explain them along the way. So the first part of this talk is centered around design. The second part is on manufacturing. I personally love design work. I spent about 7 years of my career after college working as a designer of electronic systems at Northrop Grumman. Design involves creativity, working with teams, borrowing other ideas from other areas of life, using science, technology, engineering, art, and mathematics to dream up something brand new, something that has never existed before. It's an amazing way to make a living, and I highly recommend it. So, how is design changing with new technologies? This is interesting. Designers are using things like virtual reality to better understand their designs. Virtual reality, or VR, is the use of specialized equipment, usually headsets with screens on the inside that allow a person to see and interact with a totally virtual environment. And that means it's different from where they actually are. I'm going to use that term today. So I'm in the real world and there's a virtual world, and they're two different things. So virtual reality allows you to look and interact with that virtual world. A good VR gives the person, the viewer, a window into that new world. While great VR is so convincing, so immersive, that the person starts to believe that they're in that virtual world. Now, engineers are taking the technology of virtual reality, which is usually used for entertainment, and putting it to work. Engineers are using VR to evaluate how easy or hard their products will be to put together, way in advance of actually building anything. Imagine you're in the virtual world with your design. You can make sure now, will your arm reach that screw at the end? Maybe you need a special tool to put this together. Are you going to have room for that tool? These are all examples of human factor studies. Finding these kind of issues early and fixing them early is saving engineers a lot of time and companies a lot of money every year, including teams at Northrop Grumman. Another fascinating technology that is changing how we design products is artificial intelligence, or AI for short. AI can be defined as the use of computer systems to think and work independently of humans. Here, in the beginning of AI, the goal is for computer systems to think and act like us, humans. In the near future, though, AI will be capable of exceeding human capabilities. So how can this help us in design? Well, first, let's talk about the design process. The creative process for us humans varies quite a bit, but I thought about it for a minute, and I think there are 4 common themes that can be found in the creation of a design. Number 1, purpose. Most people that call themselves a designer are designing with a goal in mind, a purpose. They need to fill a gap, overcome a problem, meet a need, etc. The second is the idea. The designer or team of designers try to address the purpose by creating an idea. To do so, they may gather data from history, new trends, hold focus groups, interviews, conduct trade studies. To develop the idea itself, they may brainstorm as a team, sketch out ideas on paper, rapid prototype something on a 3D printer. Ultimately, though, at the end of the process, an idea is created. An unproven idea, but an idea. Analysis, part 3. The modern designer will test out and analyze their ideas very often before investing much time and money, all along the process. For example, a web designer might change the color of a button and see how that changes impacts the number of clicks that button gets. They might test this idea on a small scale before enacting this change across the entire website. Analysis will measure how well your idea addresses the purpose, the problem that's trying to be solved. Number 4 is iteration. This means to make changes to your initial idea based on the results of your analysis. This will result in an altogether new idea that once again can be analyzed. This creates a cycle. Design, analysis, redesign, analysis, redesign. This cycle can then repeat itself again until the designer is happy with the analysis results and can call the design complete. Now, it's in this iterative cycle that artificial intelligence can help us. Imagine that you're designing a new bracket. You know how strong it must be, how heavy of a load it must support. You know the material you'd like to use and the mechanical properties of that material. These are all considered analysis parameters, or the assumptions that you're making. Here's how it could all work. Imagine the designer presents the initial idea to a computer system, often in the form of a 3-dimensional model. The system then takes the model and the parameters and conducts the analysis automatically, without human involvement, instead using artificial intelligence. Based on the results of the analysis, the system then automatically changes the shape or the geometry of the initial concept. This new shape can then be analyzed again and again and again. In theory, this could all happen while the designer is busy doing other work. Or better yet, they're relaxing by the ocean. To my knowledge, this is still an emerging technology, meaning it's still being developed, but it is an exciting idea for the future. Okay, let's switch gears a little bit and chat about how technology is changing how we build things, how we manufacture. After design, I spent about 6 years in our production areas as a manufacturing engineer, an assembly line manager, and then later as what we call a sub-project manager of our mechanical integration teams. That's a lot of fancy titles, but basically I help to lead and manage some of our assemblers, the people that bring our highly complex spacecraft into existence using their hands and their minds. Now, manufacturing is different from design. Manufacturing involves organization, working with teams, lots and lots of communication skills, attention to detail, and taking pride in getting high quality work done with lots of pressure and very tight schedules. It's a wild ride for sure, but extremely gratifying work. And I made some of my best friendships at work while working in production. So back to technology. Many of you have probably heard of 3D printing, or maybe even the term additive manufacturing. You may have asked yourself, why do they call it additive manufacturing? This technology uses special equipment, like a 3D printer. It also uses a 3D model of what you want to make in your computer. And finally, a layering material. The material could be anything from plastic to concrete to titanium. The list grows every year. Basically, the software takes your 3-dimensional model in the computer, which is just a data file that you can download and email like any data file. And it slices the 3D model into many layers. Each layer is then electronically sent to your 3D printer, which uses the layering material, let's say plastic in this case, to create your model one layer at a time, each layer adding on top of the previous layer. That's where the term additive comes from. When the final layer is deposited, your model is complete. This is a 3D printed rose that I made for my daughter for Valentine's Day, and it was created using a 3D printer, one layer at a time, and we were happy with the results. Now, in the past, this 3D printing technology was used to rapidly create prototypes of your designs. This helped designers to visualize their models, to better understand and share their ideas with others. Today, however, this technology is being used for the final product itself, not just the prototype. This is exciting because of the way 3D printers work. It opens up the door to many manufacturing applications. In particular, a new way to get parts in the hands of the people who need them. Okay, imagine you're an engineer supporting a remote construction site of the future. Perhaps you're making a building to house scientists studying the local environment. Your excavating equipment, or big earth movers, has just broken down, and you need to replace a part before work can restart. The part is here in Redondo Beach, California, and you are, let's say, very far away. Instead of waiting to have the part delivered to you, what if you could just print the part at your construction site and have it ready to use in just a few days? Not bad if you're working on a remote mountainous jungle off the coast of Africa. Maybe delivery would take a few weeks. It's a pretty good solution. Instead, imagine that your construction site is actually on Mars. Now, all of a sudden, this idea of printing your part on demand is kind of a game changer. In the future, it could cost pennies to email a 3D model to someone on Mars, but it still could cost millions to launch a rocket to deliver a part to Mars. Let's talk about another example. Yes, many of our products are built with machines like 3D printers and other CNC equipment, but there are still many manufacturing operations that require a human to be involved. This means that a designer needs to communicate their design to the person or team that will make it. Now, this is no small thing. Communication in general can be difficult, even just between two people. Imagine the challenges we face in a large company like Northrop Grumman, with about 90,000 employees working in over 550 facilities in every state of the country and over 25 countries all over the world. We are a huge team, and that makes the job of communicating across that team even harder. So how can technology help us communicate better? One example is our need to deliver work instructions, which is how we tell our manufacturing teams how to build a product. That's what a work instruction is. This is no instruction pamphlet or brochure like what you get with a Lego set, just pictures and arrows. No, we have to build with the highest accountability, reliability, and quality, and do it as efficiently as possible. You see, oftentimes when we send something into space, we cannot send a repair crew to go deal with a malfunctioning equipment. So we have to be sure that when we launch it, that it will work. As a designer, I used a high detailed 3D model of a product to create a two-dimensional drawing. This is time-consuming work, and it required another engineer to check my work to make sure no errors were made. We then would provide that drawing to manufacturing. Manufacturing would read and understand that drawing and break up the design, which is one thing, into the many steps required to actually build the product. They would then write down these steps in sentences and paragraphs. So follow me here. A 3D model to create a 2D drawing, and then to write what I call 1D text. We then would ask the actual assemblers, not the manufacturing engineers, the people actually putting the hardware together, to make these complex 3D products by reading the 1D text and referring to the 2D drawing. It's how we've always done it. There's a lot of energy and time that's required to ensure proper communication every step of the way. And although we are careful, mistakes still occur along the process. Now, there are engineers working around the world, some at Northrop Grumman, who think that augmented reality technology can help us solve this problem. Augmented reality is very similar to virtual reality, but they are different. Augmented reality uses special equipment, usually special large glasses, that superimpose virtual content on top of the user's view of the world. So right now I'm looking at the real world. There's a light, there's a camera, there's a monitor. But what if I needed to add to this? What if I had a countdown that told me how many minutes I had left before I needed to end the talk? And maybe that was only in my augmented reality glasses, not on the monitor, not on the camera. That's an example of augmented reality. Good AR is relevant and related to what the viewer is seeing in the real world. It makes sense. It's contextual, I like to call it. Great AR changes when the user interacts with it, and it changes in response to the real world environment also in view. So you can imagine a little augmented reality character that's here to help me give my talk. And maybe it recognizes that there's a table in front of me, and the augmented reality character can move from the table to the floor and back. In that sense, the augmented reality character responds to the real world environment. Again, that topic of immersion comes into play. I now start to believe that that digital character, that augmented reality content is actually with me. That's great AR. So back to improving our work instructions. Imagine looking at a box of parts, and you're looking at it with special AR glasses. The computer program running on the glasses scans the environment, maybe scans a barcode. It recognizes what product you're looking at, what step of the assembly process you're in. You then see a digital 3D model. Instead of a character this time, you instead see a digital 3D model of the next part to be installed. You see its location, its orientation, you see where not to put your hands for safety reasons, and maybe even you're shown what tools you should be using when putting this thing together. This idea is called augmented reality work instructions, or I like to call it ARWI for short. It's a technology that I am passionate about, I enjoy talking about, as you can probably tell. Now, I have more technologies that I'd love to share with you, but I think I've run out of time here. Perhaps I'll make a part 2 to this video next summer if you've enjoyed it. I hope you learned something new today and that you're excited and inspired to help us as we use technology to change how we design and build things. Thank you.